So let's share. Okay. So again, yesterday we looked at angles that would swing between 0 and 90 degrees. Now we're going to delve into the other quadrants. It's a fancy term for the different sectors of the XY plane. So if you look here, have a nice little picture. Okay, so yesterday we really only were concerned about like this section here, okay? That is it, okay? But obviously, if you think about it, and then we looked at this with coterminal angles, the terminal arm can swing in any of the quadrants and it could spin repeatedly, all right? So if you look at the diagram, so the quadrant between 0 and 90 we call quadrant 1, all right? So here, right, so again, I have my vertex, I have my initial arm, and then I have now my terminal arm here, okay? And again, this is some point, right? And this swing of theta takes us into quadrant 2. So quadrant 2 is between 90 and 180. So notice what happens. If you remember, what did we do yesterday? Like if I had to swing, and if I had a point here, we dropped the perpendicular, and then I had my 90 degree, or my, my 90 degree triangle in that quadrant, and then I could use SOHCAHTOA to find all the trig ratios and the angle of theta. Here, when I drop myself a nice little perpendicular, right, I have this angle here. So notice one kind of slight little difference that you should look at is that I have called this one, this angle, I've used the symbol beta, okay? So I'm in the quadrant where theta is between 90 and 180, but this beta here, and I have it labeled there, and I'll just write it again. Beta is what we call the related acute angle. All right. Oh, 1 second. I just have to mute myself and just yell at one of my children to get started with school. All right, I'm good. So every terminal arm that swings either in quadrant 1, 2, 3, or 4 will have a related acute angle associated with it. Okay. And if you look here, like, so this is quadrant 2. Quadrant 3 is between 180 and 270. And then 270 and 360 is quadrant 4. So what we're going to do is we're going to essentially look at this exact same type of question as yesterday, just now I am going to be in different quadrants. All right. So let's look at one here, which is just going to be going over what we did yesterday. So I have a point. Details hidden while you share your screen. Oh, cool. Okay. Oh, my kids' DanTDM videos. That's exciting. So again, I have a point here, root 3 and 1. Okay. the swing is an angle of theta. And then just like yesterday, what do we do? Well, I dropped a perpendicular, right? And then I know this length is √3, and this length is 1, right? So the only thing that we have to figure out is r. And again, how do we figure out r? Well, r is just going to be the square root of √3 squared plus 1 squared. So that is going to be 3 plus 1, which is conveniently 4. So r is 2. That's nice. Okay. So again, hopefully none of that is new. And everyone is totally aware of how we did that. Okay. Next, we would find out our trig ratio. So we'd say, okay, sine theta equals opposite over hypotenuse, or y over r, right? So 1 over 2. Cos of theta is x over r. So √3 over 2. And then tangent of theta, which is y over x, which is 1 over √3. So those are our 3 primary trig ratios, and we always leave them in exact form, no decimals, because decimals are gross. Okay. And then the next thing we would do is we'd be like, hey, how do I find theta? Okay, and the way I would find theta is using one of those ratios. Okay. So, we do theta equals sine -1 of 1/2. And again, if I go here, if we go to decimals for a second, just and again, just to show you how I can use decimals to solve this. Again, decimals default is radians. So what you have to do is you have to hit the wrench where it says graph settings, and then see at the bottom here where it says radians and degrees, click on degrees. All right. And then get the exponent sine -1, and then 1 divided by 2. And I get 30. So hopefully someone recognized that this actually here, this one here, is a special triangle. Okay. Okay, yeah, that's fine. So this angle is 30 degrees. All right, cool that. And again, right now we are in quadrant 1. And essentially what we're going to do next is do the same thing, but we are going to now move into quadrant 2. All right. So let's do that. So have quadrant 2. All right. So again, my point here is -√3 and 1. All right. I didn't like that line. Okay, so notice the difference that now this swing, right? This is theta. So theta is now past 90. And then I'm going to do the same thing. I drop a perpendicular. Okay, so it's now I'm in quadrant number 2. Okay, make this 90 here. Okay. Now, in terms of labeling the triangle, notice the point. I'm using the same, like we're going to have the same triangle, just the x value changes. All right. So that means this is -√3 and this is 1. Okay, now what is r? Well, you could go through the whole process of finding r, but notice I'm using like the same points, just I'm going to be alternating whether x or y are negative. Okay, so r here is going to be 2. And if you don't believe me, I'll just quickly show you that you would just do this. Negative root 3 squared plus 1 squared, which would give me the same thing I had before, 3 plus 1, which is going to be 4. Or square root of 4, which is 2. Okay? So the one new thing is, remember, so this angle in here, this is, I'm going to call it beta. Okay? And beta is the related acute angle. Okay? Anybody want to guess what beta is? Anyone out there listening? Out there on the radio waves?
30.
Yeah, thank you. Amazing. Okay, this beta is 30. Okay. Now again, why? Well, think about it. This is the same radius, right? Like all I'm doing here is, right? Like I'm spinning this around, you know, when I get over here, right? It's the same radius. Everything is the same. It's just the negative denotes that I'm in a different quadrant, which means that my related acute is going to be, okay? So using logic, we can figure, like we notice that right away. We're like, well, hey, like I know my related acute has to be 30. And then now we say, okay, let's just write our ratios out. So I'm going to have sine theta. So again, notice I'm using this notation, or I'm using theta, but I'm using this triangle to label, right? So like from my related acute, my sine is going to be y over r, right? So 1/2. Cos theta is going to be x over r, which is negative root 3 over 2. And then tangent of theta is y over x. So 1 over negative root 3. Okay? So if I look, if you just will allow me, I'm just going to flip back. Okay, like these ratios from quadrant 1 are the same in quadrant 2. The only difference is cos and tangent are negative. All right. Everybody okay with that? And then now this is where the calculator, you have to be aware of or we have to not 100% fully trust any calculator we use, because we know if I just, you know, if we say, okay, well, what is theta? Okay, well, if I look at this diagram, right, if we know that beta is 30 degrees, right? So theta is just going to be 180 minus the related acute angle. Okay? Which means that's going to be 180 minus 30, which means it'll be 150. Okay? And this makes sense when we think we're like, is 150 in quadrant 2? Yeah, this is 150. So like, I feel good about that. What you just have to be wary of is this, right? If we use the calculator, right, I have sine -1. I have cos -1, which is negative root 3 over 2. And then I have tan -1 of 1 over negative root 3. Okay? So if I have all my ratios, that means I can use any of these to find out theta, and I'm going to get a right answer. Now, if I use Desmos, here's what the problem comes in. So cos -1, oops, 10 -1 bracket. We had that for and divided by 2. This one was what was it again? -1/√3, right? -1 divided by √3. Okay. So check it out. When I use each ratio, like if I use sine, I get 30. If I use cos, I get 150. If I use tangent, I get -30. So what you have to understand is that I'm going to be getting different values depending on where I am on the XY plane, like which quadrant. And your calculator can only give you one answer. And unfortunately, when we look at our trig ratios, when I'm swinging into different quadrants, right? For example, if you look here, look at the ratio, sine theta 1/2. Look at this one, sine theta is 1/2. So like in quadrant 1 and 2, sine theta has the same ratios. So it makes sense that if you use sine theta, your calculator is going to give you this answer because your calculator is assuming that you're in this quadrant, right? Quadrant 1. All right. Whereas when we look at this question here, I know I can't use sine theta because sine theta will give me an answer in quadrant 1. I know I'm in quadrant 2. And again, if we look at, go back to the calculator in a sec, right? Then, like, if I use cos will always give us the answer for like anything in quadrant 2, okay, when it's negative like this. So that's why drawing the picture is important, so that I know, I'm looking at my picture, I'm like, okay, I know the terminal arm is in quadrant 2, so that means my answer has to be between 90 and 180. And again, when we look at all of these values here, right, sine gives me an answer in quadrant 1, cos gives me an answer in quadrant 2, which is which is the correct one. Check out tan. Tan gives me an answer in quadrant 4. Huh, weird. So that being said, let's do the exact same thing, but now we're gonna take this terminal arm and we're going to swing it into quadrant 3. All right. So we got that. Now, why didn't I use this before? All right. All right, dumb teacher. Okay. So again, this point is -√3 and -1. All right, so that's my terminal arm. So now check out theta is this whole thing. And then when I draw perpendicular, okay, remember, notice we're always dropping out perpendicular, which means that the point has to, like from this point, it has to go onto the x-axis. And that is right angle. And then I'll just remember that this angle here is my related acute, which I'll call beta. And then we can include our values. So notice the x value is -√3. So that means this is -√3. The y value is -1. So that means this is -1. And notice my radius always staying positive. Okay. So now when we kind of do the same thing, we say, okay, I can write out my ratios. Sine theta, okay, using my angle of reference being the related acute is opposite over hypotenuse, or y over r. So notice now sine is negative. Cos theta is adjacent over hypotenuse. So here, cos is negative, right? And then tan of theta, which is y over x. So notice it's negative and a negative. So those cancel each other out. All right. So in this quadrant, tangent is positive. I just heard someone. Is there a question or something? Or let's see. How can the length of something be negative? Oh, so great question. So we're using the negative to tell us where we are on the xy plane. So you're right. This length, if I were to highlight it here, like what is this length? This length is √3. Okay. But I'm using the negative to put us in a specific part of the xy axis, xy plane. You understand that? And the same thing with this. Like this is 1, but we're using the negatives because we're now, we're letting the arm know that it has to swing somewhere where the x value is -3 and the y value is -1. Does that make sense? Yeah. It's a good. It's a common question because when you look at it, you're like, hey, like lengths can't be negative, and you're right. But we use the negatives to, it's essentially like giving direction. Because if you were like programming this and you use positives all the time, then you'd only be in quadrant 1. Okay. All right. So cool. Good question. Thank you. And then now, again, what's my beta? Like we know my related acute here is, this is still 30. It's the same arm that's swinging, but in the third quadrant. Okay. So when I think about this using the picture, like what is theta? Well, theta here is going to be, if I look like I colored in this much, right? This is 180, right? Plus this little chunk, which is beta. So that's essentially like the formula for how to find how to find the full swing, right? So that means when I look at this, right, we know theta is going to be 180 plus 30. So theta equals 210. Okay, and that makes sense because in this quadrant, right, quadrant 3 is between 180 and 270. Now, what I want just to kind of run the same experiment, right? If I use my calculator, so let's go back to our decimals thing here. So if I change it, this becomes negative, this is negative, and then tangent just stays positive, right? So check it out. So if you use sine to figure this out, you get -30. Okay. And if you think about it, where's -30? Well, -30 is actually like here, right? Like this is 30. Like it will be this swing, which isn't where I am, right? We're in quadrant 3. I'm not in quadrant 4. Okay. So when I look at the calculations here, like notice sine gives me -30, cos gives me 150, tan gives me 30. So like, what is tan giving me? Tan is giving me the related acute angle. Cos is giving me the swing in quadrant 2, and then sine is giving me essentially the related acute, but just a negative swing. So that's why you need to like look at the picture to make sure that you are determining the correct angles. Okay. So here in this section, let me just write that down. If we used, right, if we used tan inverse 1/√3, then we'd get 30, right? But, right, the 30 degrees is the related acute angle. So we just, like, again, we use our knowledge of the graph in standard position, like this picture right here, and I say, oh, okay, well, 30 can't be correct because where's 30? 30 is here. I'm not in quadrant 1, I'm in quadrant 3. So in quadrant 3, if you use tan, you'll always get the related acute, and then you can just use this formula to figure it out. Okay? But just when we go back, if we go here, right, in quadrant 1, right, they're like, these are all positive, right? All the ratios, sine, cos, and tan are positive. If I look in quadrant 2, the only one that's positive is sine. Okay. In quadrant 3, the one we just did, the only one that is positive is tangent, right? And then, well, let's do the next one, and hopefully your intuition is telling you that I'm pretty sure cos is going to be positive in quadrant 4. All right, so now I'm in this quadrant here. So this point is √3 and -1. Okay, so now I've now swung into the 4th quadrant. And again, we do the same thing, right? I drop this down. Okay. And then again, what's the x value? Well, this is √3. Now this is, again, we're like it was mentioned before, this is, the length is 1, but I'm putting the negative because it's the negative y quadrant. And then my radius is 2. And then again, that means that this chunk here, this little one here, is my related acute, which we know is 30. It's the same. Okay. So again, if we think about it, if I, like, you know, how do I come up with a formula for this? Well, think about it. If I go all the way around, right, that's 360. But if I want to get rid of this chunk here, right, get rid of that, then that'll give me the whole swing of theta. So here theta would be is going to be 360 minus my related acute. So that means because I know my related acute, I calculated, it's no big deal, right? 360 minus 30, which is going to be 330. So this whole swing here, right? That is 330. Now we'll run the same experiment where we write our ratios out. So again, sine is going to be, and again, we're using the related acute as our kind of angle of reference. Sine is -1 over 2. Cos theta is adjacent over hypotenuse, so check it out. Yeah, cos is positive. Congratulations. And then tan is -1 over √3. Okay? So again, in this quadrant, when we think about it, well, not when we think about it, when we look at the ratios, right, in this quadrant, cosine is positive. And same deal, if we go to our calculator, and this is where the picture is important, right? Sine is negative, so cosine is positive, and tan, I think, was negative, right? If you look in this quadrant, when I use either of the ratios, like sine and tan give me, essentially, they tell me the answers in quadrant 4. But all of these ratios, when I solve for theta, will give me the value of the related acute angle. Like here, the negative just means the direction of the swing. Okay, this one is negative, this one is negative, this one's positive, but they're all 30. Okay. So in this quadrant here, we can just say that all the ratios will give us beta. Okay, so that means what we got to do is just make sure we remember this. Okay. And again, it just comes from the picture. All right. So let's try one. Okay. So now we're doing the exact same question as yesterday. Just now we are moving into another quadrant. So we have a point -2 and 4. It's on terminal arm. We want to find the exact primary insured ratios for theta. So let's draw ourselves a picture. Okay, so again, notice the point, the x value is negative, the y value is positive. So it's going to be in this in quadrant 2. All right. And again, I'm just going to label the point here. We're not like measuring out to make sure that we have the point in the correct spot. You know, I mean, you can if you want to, but it's not really necessary, right? So I didn't like how I drew that one. Much nicer. Okay, so that is theta. And then we drop a perpendicular down. And again, we know this coordinate is -2 and 4. So that means that the x value is -2. So I'm going to write -2 down here. The y value is 4. So here we got to figure out what r is. Okay. And remember, r is just going to be the square root of -2 squared plus 4 squared. So that's going to be 4 plus 16. And that is just going to be square root of 20. Okay, and again, we're leaving them in exact forms, so I don't want to see, like, no decimals. Okay. So now, what we do, we'll just write out our ratios. We'll have to label beta. So again, no worries. So this angle here is beta. So sine is, remember, y over r. So it's going to be 4 over square root of 20. cosine is adjacent over hypotenuse, or x over r. So that is negative 4 over 20, or root 20. And then tangent is y over x. So those are our exact primary trig ratios. All right. So the last thing we want to do is we want to figure out, okay, well, let's find theta. Okay. So again, how do we find theta? Well, to find theta, we are going to do the inverse, but so we're just remember, if I go back here, okay, because this question, we're in quadrant 2. So let's see, what do we do in quadrant 2? Oops, here, right? So I wrote down here that cosine will always give us the full swing. Okay, cool. So that means that theta.
Sir,
what's up?
I think the cosine theta, I think it equaled -2 over root 20.
Oh gosh, I wrote -4. Sweet. Thank you for catching that. Yeah, because then that would give me that would totally mess me up. So yeah, so here we'll use cos, or the cos ratio. Right, so it'll be cos -1 of -2 over root 20. And then again, if I go to my decimals calculator, I'll go to my cos part. So it's -2 over square root 20. And so I look 116.5. So I know I'm in quadrant 2, which is good. Okay. So theta is 116.5 degrees. Okay. Now, just one thing just to add here. If we used sine ratio, okay, let's just do that experiment, because if you use sine, then your answer, you'd get the related acute, and then you'd have to subtract it. Okay, so if we did sine -1 of 4 over square root of 20. So if you use that one, and if we go back to Desmos and plug that in, -4 over square root 20, which are not negative, positive. So I get 63. So again, when you kind of run this simulation, you're like, yo, okay. And again, this is where you're actively thinking, right? Like, we're not just doing brainless mathematics. We're saying, okay, theta is 63, but hold on, 63 would be like in this quadrant. So like my answer can't be 63. And we know in quadrant 1, right, if I use cosine cotangent, I get the related acute. So actually 63 is the related acute, right? So then you could, to find theta, you would just go 180 minus the related acute. Okay? So again, there's different ways to go about it. Like, if you forgot that cos will always give you the right answer in quadrant 2, just remember, you have to just pay attention to the angle that you get. Okay, because again, if you and it happens a lot, students just say, oh, they're like theta 63, and it's like, well, hold on, look at your picture. Right, in quadrant 2, I'm between 90 and 180. 63 is here, so it can't be the right answer. Okay. So let's do one more, and then we are done. All right. So this one's a little bit different, but we're doing the same thing. Okay, just where you're given information in kind of a different way. So I have cos theta is -4/7, and the terminal arm is in quadrant 3. Okay, cool. So we want to figure out the ratios of sine theta and tan theta. All right, cool. So here what I'm going to do is just draw myself a little picture. Again, notice it doesn't tell you explicitly like, hey, draw a picture, but like, I mean, if you look at the lessons that we've done, yesterday and today, drawing a picture is key because it's going to help you understand where you are, which will then determine the angles that you're looking for or the ratio they're trying to find. So again, quadrant 3 is here. Okay. So that means I'm mainly focused in what is going to happen in this section right here. Okay. So what I'll do, I'll just draw, I mean, I'm still going to draw. Okay, so I have this right here is theta. And again, what do? We draw ourselves a perpendicular. Okay. And then remember, this is like -x, -y, and r. Okay. And yeah, in here, right, remember this chunk here is beta. So again, what do we know? Well, we're given, when we look at the question, we're given one ratio, right? We're given cos theta equals -4/7, okay? So notice when we think about it, like if we go back here, like, go back here. See how like cos is negative here, and cos is negative here, right? So in 2 quadrants, cos is negative. So it's key that they're telling us that we're in quadrant 3, because then if they didn't, then I'd have to look at both situations. So again, all you have to remember here is that the ratio for cos is x/r, right? So that means that the x here has to be negative because the bottom part of the ratio is the radius, which is never negative, okay? So -4/7. So that means that this value here, right? I can erase the unknown and say, okay, this is going to be -4. And then this is going to be 7, which means that what I have to figure out is I just have to figure out essentially like this side, okay? Which isn't too bad, right? If you remember, like, here what we just use the formula r² equals x² plus y². And then now this is just going to be r² minus x² equals y², which will just be the square root of all this. And then if we plug that in, so it's going to be 7² minus 4², right? Yeah. So that's going to be 49 take away 16. And then that's going to be, so 49 take away 10 is 39. And then 39 take away 6 is 33. All right. So that means that this value down here, right? So this, if I erase this thing here, so I know that this is now right? The square root of 33, but it has to be negative because, again, I'm in the negative y. Like every point in the third quadrant, the y value is negative. Okay. So now that I have this information, now I can write, well, what's the value, or not the value, what's the ratio of sine theta in this situation? Well, I know theta's in quadrant 3. I'm going to use the related acute angle in the triangle here. So it's opposite over hypotenuse, right, or y over r. It's going to be negative root 33 over 7. And then the other one was tangent. And again, tangent is y over x. So it's going to be negative root 33 over negative 4. So then it just becomes positive. And that is it for the question. Okay. Because all it wanted was just the ratios. All right. Now it didn't ask for theta, but what the hell? Let's find theta. So again, if I'm in quadrant 3, if I go back to our little, where was here? Quadrant 3. So when we are here, if we use tan, then we'll get the related acute. Okay, so let's just do that, right? So let's just go down here. Let's find theta, okay? So again, if we use tangent, then we'll get the related acute. So let's check it out. Right, so it was 33 over 4, right? Yeah. So I get 55. All right. So again, when we're doing this, right? Okay, I guess theta equals 55. And again, don't be like, I'm done, great, cool. Okay, no, because I'm not in quadrant 1. Okay. So all we got to do is just remember, right? In quadrant 3, right? In quadrant 3, right? Tan theta gives us the related acute. So that means beta equals 55. So if I go up here, so this equals 55. And then again, what's the rule here? Well, theta is going to be 180 plus beta. So that's what we're going to do down here, right? So in quadrant 3, theta is 180 plus the related acute. So it's going to be 180 plus 55. So theta is going to be 235 degrees. All right. So again, when you look at the mathematics, like we're just using sine, the ratios for sine, cos, and tan, nothing crazy. But again, drawing the picture, that all that stuff is new. But you know, generally, you know, as human beings, we like drawing pictures and telling stories and stuff. So like, hopefully you understand how to draw the picture, and then from there, everything else is just like grade 10 stuff. All right. So that is the last example. So we shall stop sharing. And what I'll do is I will post the homework. And you can get started.